let's discuss the continuity of this function here, this piecewise function. And we have three pieces, and they all revolve around a -4 at x. So let's discuss the continuity of this function at the interesting point, which of course is -4. Let's start by bringing back our conditions of continuity so we know what it is that we're looking at. And we want to know, first of all, is f of a defined? And a, in our case, is -4. So we'll put -4 into our function, and let's see what happens, if anything. So at x equals -4, here it is right here. At x equals -4, so if x is -4, then this piece of the middle piece of the function tells us that f of x is equal to 0. So we will write f of x equals 0. So condition 1 is satisfied, right? F of a is defined. Now condition 2, we want to explore the limit to see if the limit exists. So let's look at -4 here and see what happens as we approach -4. So we can approach from the left, right, below -4, and we can approach from the right, above -4. Now condition 2, we want to look at the function to see if the limit exists as we approach -4. So we want to look at the limit as x approaches -4 of f of x. But now look what we have here. We can approach actually from the left because we're a little bit less than -4, and we can approach from the right because we're a little bit above -4. We know what happens when we're to the left of -4. We use this piece, and we can determine what happens when we're to the right of -4. We'll use this piece. So let's take a look at this. The limit, let's get this thing to right here. So the limit as x approaches -4 from the left. Now as we're approaching from the left, we're a little bit less than -4. So up here, if we're less than -4, we're going to use this top piece of the function. So we're going to look at this. X squared plus 8x plus 13. And because this is a polynomial function, we can just substitute -4 squared plus 8 times -4 plus 13. Now when I computed that, I got -3. So what we're saying here is this. As we approach -4 from the left, this function up here, right, our function, as we approach -4 from the left, we are approaching -3. Let's see what happens as we approach from the right. So as we come in from the right, let's take a look at the limit as x approaches -4 from the right, a plus. Now, what do we got here as we approach from the right? As we approach from the right, we're a little bit bigger than -4, so we're going to use this piece right here. So this is just a constant. So we're going to have here -3, and we know that the limit of a constant is just that constant itself. And now what we've got is this. As we approach -4 from the left side, the function's approaching -3. As we approach from the right side, the function's approaching -3. And because the limit from the left equals the limit from the right, we can say that the limit exists. So we will say the limit as x approaches -4 of f of x exists, and it equals -3. And the third condition says, what does the limit of the function as we approach our a equal the function value at a? So look at what we've got here. We've got the limit. Let's take a look at those. I'll write those down. In number 3, the limit as x approaches -4 of f of x, actually x, we know what x is. Well, let's say this. This is equal to what? -3. And also, we know that f of -4 is equal to -3. And because these two are equal, right, we're going to say the limit as x approaches -4 of f of x is equal to f of -4. And that's true since -3 equals -3. We will say that condition 3 is satisfied. So let's just go back and see what we have. Condition 1 is satisfied. So let's just say it. Condition 1 is satisfied. Condition 2, the limit exists. Condition 2 is satisfied. And condition 3 says that the limit is equal to the function value. So down here, let's say condition 3 is satisfied. And now I'm going to say this. Because all three conditions are satisfied, this function is continuous at -4. So I'm going to write that. So let's write it here. Because all three conditions, all three continuity conditions are satisfied, we conclude that f of x is continuous at x equals -4. And like we said before, we don't want to just say f of x is continuous at x equals -4. We want to say why. And we're doing that here. We're saying because all three conditions are satisfied, we conclude that the function is continuous.